we can apply our process and add 3 fractions together, which means we need the least common denominator for all 3. All 3 have to match. Prime factorizations for 2, 4, and 8. 2 is just 2. 4 is 2 squared. 8 is 2 cubed. So the least common multiple, the only base we have is 2. And the highest power shown is cubed. 2 cubed is 8. So all of these have to be rewritten over 8. And what a blessing. One of them's already done for us. The 1/8 doesn't have to change. It's already over 8. 2 times what is 8? 2 times 4 is 8. So we have to do times 4 on the top of that one as well. 1 times 4 is 4. 4 times what is 8? That's times 2. So we have to do times 2 on the top as well. 1 times 2 is 2. And this one didn't change, but we could still walk through it the same way if we want. 8 times what is 8? Times 1. So we do times 1 on the top as well. 1 times 1 is 1. So this would be 4 plus 2 plus 1 all over 8. 6 plus 1 makes 7. So the answer is 7/8. Let's do another. Which of course will be a little more complicated. We're not going to get to keep one of our fractions this time. 2/3 plus 2/9 plus 3/4. So we need prime factorizations for 3, 4, and 9. 3, 9, and 4, and that'll help us find the least common multiple. 3 is just 3. 9 is 3 squared. 4 is 2 squared. All the bases we have are 2 and 3. Highest power shown for 2 is 2 squared. Highest power shown for 3 is 3 squared. That's 4 times 9. That's 36. So each of these has to be rewritten over 36. Three times what is 36? Well, that's 3 times 12. So we do times 12 on the top as well. 2 times 12 is 24. 9 times what is 36? That's times 4. So we have to do times 4 on the top as well. 2 times 4 is 8. 4 times what is 36? That's times 9. So we have to do times 9 on the top as well. 3 times 9 is 27. So on top, 24 plus 8 plus 27, all over 36. 24 plus 8 is 32. So 32 plus 27 all over 36. 32 plus 27 is 59. So 59 over 36, which is accepted. Isn't this fun? I think these are kind of fun. Let's look at 57 over 100. Plus 3/4. plus 9/10. 100. We look at the factor tree, that's 10 times 10. Each of those 10s is 2 times 5. 100 is 2 squared, 5 squared. 4 is 2 squared. 10 is 2 times 5. That means least common multiple. Only bases are 2 and 5. Highest shown power of both is squared. 4 times 25 makes 100. Woohoo, one of them gets to stay the way it is. 57 over 100 is already what we need. For 4, we would have to do 4 times 25 to get to 100. So on top, 3 times 25 would be 75. 10 times 10 to make 100. So times 10 on top, 9 times 10 is 90. This is 57 plus 75 plus 90 all over 100. 57 plus 75 would be 132. 132 plus 90 over 100. And then 132 plus 90. 222 over 100. And a funny thing happens when we put this in. There wasn't any mixed number in the problem. We have had answers of improper fractions before, and it was fine. This time, it says that's incorrect. And that's because we have that special instruction I warned you about last time, where it says type a whole number fraction or mixed number. If it specifically says that a mixed number can be put in and we get an improper fraction, it will only accept a mixed number. So we have to divide 222 divided by 100. 100 goes into 222 twice, with 22 left over. If we put in 2 and 22 100ths, it still tells us the same thing. What did we do wrong? We converted it to a mixed number. 22 over 100 can be reduced. 22 is 2 times 11. 100 is 2 times 50. The 2's cancel, so this is actually 2 and 11/50. And sure enough, that one will be accepted. So remember, it's not enough to change it to a mixed number. The fraction piece of it still needs to be reduced. 2 and 11/50. Let's do another. I promise we'll do some subtraction before we're done. Let's look at 3/28 plus 3/35 plus 7/20. Remember, addition and subtraction is all the same. Only difference is at the end whether we're adding across the top or subtracting across the top. Prime factorizations. 28 4 times 7, that's 2 times 2. 28 is 2 squared times 7. 35, that's 5 times 7. Both of those are prime. 20, it's 4 times 5. 4 is 2 times 2. 20 is 2 squared times 5. Once we have the prime factorizations, we can find the least common multiple. Every base we have is just 2 times 5 times 7. Highest power of 2 we have is 2 squared. Highest power of 5 and 7 are just the first power. That's 4 times 5 times 7. 20 times 7. 140. So all three of these fractions need to be rewritten as fractions over 140. Notice once we wrote this out, 4 times 5 gives us the 20, 4 times 7 gives us the 28, 5 times 7 gives us the 35. Knowing that 140 is 4 times 5 times 7 will help us here. 28 times what is 140? There's the 28, 4 times 7. So times 5. Whatever we do on the bottom, we have to do on the top. 35 times what is 140? Well, there's the 35, 5 times 7. So times 4 makes the 140. Whatever we do on the bottom, we do on top. And then 20 times what is 140? 4 times 5 is the 20. So times 7 gives us the 140. Whatever we do on the bottom, we have to do on top. Again, that's why we get equivalent fractions, because times 5 on top times 5 on the bottom is times 5 over 5. That's times 1. Times 1 doesn't change the value, just makes it look different when we do it times 5 times 5. 3 times 5 is 15. 3 times 4 is 12. 7 times 7 is 49. So this is 15 plus 12 plus 49 all over 140. That's 17 plus 49 over 140. Sorry, not 17, 27. 27 plus 49. And 27 plus 49 is 76. 76 over 140. Well, it's not improper, so we don't have to worry about a mixed number, but both are even, so it at least reduces dividing both by 2. $76 divided by 2. 2 goes into 7 3 times. 2 goes into 16 8 times. So that's 2 times 38. 140 is 2 times 70. The 2's cancel. But 38 and 70 can both be divided by 2 again. 38 divided by 2 is 19. 70 divided by 2 is 35. So it looks like we have 19 over 35. Which is accepted. Five sixths minus 5 twelfths. And this isn't 0. At no point are we doing 5 minus 5 because these numbers are not the same on the bottom. We can't add or subtract until the numbers on the bottom are the same. But if we do times 2 and times 2, because the least common multiple of 6 and 12 would be 12, that turns these into 10 twelfths minus 5 twelfths, which is 10 minus 5 twelfths. Our answer would be 5 twelfths. So again, when the least common multiple is already one of the numbers, it's quicker just to think, how do we multiply up the other one and just do that? We could still do LCD method. And in this next one, we're going to do LCD method. By the way, if you've noticed that I'm switching back and forth between LCM and LCD, LCM is least common multiple. LCD is least common denominator. And in this case, they're interchangeable because the least common denominator is just the least common multiple of the two denominators. So those two numbers on the bottom, when we're finding the least common multiple of them, we're actually finding something called the least common denominator. But you may have noticed I'm trying to avoid words like numerator and denominator. I know you know that numerator is the top number, denominator is the bottom number, but why repeat these 5-syllable, 4-syllable words when I can just say top and bottom? Gets us through more problems quicker. More examples we see, hopefully the better we feel. Hopefully, even if you're a little concerned about all the multiplication and division involved in these addition and subtraction of fraction problems, you're feeling better about the process. Five is just 5. 6 is 2 times 3. The least common multiple of these numbers would be all the bases we have, 2 times 3 times 5, raised to the highest powers we have. That's just the first. 2 times 3 is 6, times 5 is 30. These need to be rewritten as fractions over 30. How do we get there? Well, it's times 6. 5 times 6 is 30. Whatever we do on the bottom, we do on the top. 6 times 5 is 30. Whatever we do on the bottom, we do on the top. 4 times 6 is 24. 1 times 5 is 5. This is 24 minus 5 all over 30, which is 19 thirtieths. Let's take a look at 3/5 minus 1/7. Five is just 5. 7 is just 7. So the least common multiple is just 5 times 7, 35. Two fractions over 35. How do we get there? 5 times what is 35? Times 7. Whatever we do on the bottom, we do on the top. 7 times what is 35? 5. Whatever we do on the bottom, we do on the top. 3 times 7 is 21. 1 times 5 is 5. 21 minus 5 over 35 is 16. over 35. Nine 14ths minus 4/9. 14 is 2 times 7. 9 is 3 squared. The least common multiple would be 2 times 3 times 7. Raised to the highest power shown. Highest power of 3 is 3 squared. The rest are 2 to the first and 7 to the first. That's 2 times 9 times 7. That's 18 times 7. And that's a problem for doing by hand. 7 times 8 is 56. Carry the 5. 7 times 1 is 7. Plus 5 is 12. 126 is the least common multiple. 2 fractions over 126 instead of over 14 and 9. How do we get there? 14 times what is 126? There's the 14, so times 9. Whatever we do on the bottom, we do on the top. 9 times what is 126? There's the 9. So 9 times 2 times 7, 9 times 14. Whatever we do on the bottom, we do on the top. 9 times 9 is 81. 4 times 14 is 56. This is 81 minus 56 all over 126. 81 minus 56 is 25. 25 over 126. Okay, I'd like to do one final problem. Let me pick a good one. Why not? Gonna skip to the last one. It's as good as any. 37 over 52 minus 5 over 28. I know we did a lot more addition than subtraction, but I'll say it one last time. It's the same thing. 52. Let's do a factor tree. It's 26 times 2. 26 is 13 times 2. So 52 is 2 squared times 13. What about 28? (28) is 2 times 14. 14 is 2 times 7. So that's 2 squared times 7. The least common multiple would be 2 times 7 times 13. That's all our bases. Raised to the highest shown power. So the 2 is squared, the rest are to the first. Least common multiple is 4 times 7 times 13, which is 28 times 13. Ooh. This is why you need to know how to multiply. 8 times 3, 4, carry the 2. 6, 8, 4, 8, 2, 364. So 364 becomes the new number on the bottom. How do we get there? 52 times what? Well, 4 times 13 is the 52, so this is times 7. Whatever we do on the bottom, we do on the top. 28 times 13, whatever we do on the bottom, we do on the top. 37 times 7 is 259. 13 times 5 is 65. This is 259 minus 65 all over 364. $259 minus 65. That's 194 over 364. We can reduce. 194 divided by 2 is 97. 364 divided by 2 is 182. Is 97 over 182 acceptable? It is. So 97 over 182 doesn't reduce any further. Okay, so now you know how to add and subtract fractions. Please practice. We're going to pick up with addition and subtraction of mixed numbers next time. I'll see you then. So when we multiplied and divided mixed numbers, the number one rule was we had to change the mixed number to an improper fraction before we did our work. With addition and subtraction, that will still work, but we also don't have to change to improper fractions first. For instance, if we had 6 1/3 plus 5 2/9, we can go improper. 18 plus 1 makes 19/3, plus 45 plus 2 makes 47/9. The common denominator would be 9. That means 47/9 doesn't change, but to go from 3 to 9, that's times 3. We go times 3 on the top. 19 times 3 is 57. So this is 57/9 plus 47/9. 57 plus 47 is 104. So our answer so far is 104/9, and we're going to change this back to a mixed number by dividing. 104 divided by 9. 9 goes into 10 once. 9 goes into 14 once. There would be a remainder of 5, which we put over 9. 11 5/9. Put that in just to make sure we were correct, and this is the right answer. Now, this problem done this way, this addition of mixed numbers, required some multiplication, required some division. In there, there was some subtraction. So all four of our main operations are at play when we do it this way. But my point in the beginning was with addition and subtraction of mixed numbers, we don't have to go that route. With multiplication, we would get the wrong answer. But keep in mind that a mixed number, 6 1/3 means 6 plus 1/3. 5 2/9 means 5 plus 2/9. And we can add in any order. So if we change the order around, this would be 6 plus 5 plus 1/3 plus 2/9. 6 plus 5 is 11 plus, this would be 3/9 plus 2/9, 11 and 5/9, because 11 plus 5/9 is the definition of the mixed number. This is also why when we multiply, we can't do it that way, because when it's not all addition, when there's a multiplication in there, we can't just change the order around like we can this way. So for adding and subtracting mixed numbers, we can add the whole number part and add the fraction part. Let's do another. 1 1/6 plus 6 2/3. This is written vertically, no difference than if it's written horizontally. This actually just gives us space over here to get our common denominators. So the common denominator for 3 and 6 would be 6. So this one stays 1 1/6. But here we're going to be adding 6 and some number of sixths. To go from 3 to 6, it's times 2. 2 times 2 is 4. 1 plus 6 is 7. 1/6 plus 4/6 is 5/6. So 7 and 5/6. Let's do another. Our next one's going to be given as 5 3/4 plus 3 4/5. We need to change them so that they have a common denominator. And for 4 and 5, that denominator is going to be 20. So 5 and some number of 20ths. How did we go from 4 to 20? That's times 5. 3 times 5 would be 15. How do we go from 5 to 20? That's times 4. So 4 times 4 would be 16. When we add these, we get 8 and 31/20. And we can't use this as an answer. Why not? Well, we turn improper fractions into mixed numbers. Therefore, mixed numbers can't have improper fractions inside of them. So what we need to do is carry the 1, but a mixed number version of that. Watch this. 8 and 31/20 is 8 plus 31/20. If we change 31/20 to a mixed number, we get a remainder of 11, which goes over 20. 31/20 itself is 1 and 11/20, and we add the 1 to the whole number we already had. Final answer, 9 and 11/20. So make sure when you get your final mixed number form that there is not an improper fraction in what you're trying to use as your final answer. This does not become an issue if you take it to improper fractions first. So if you're choosing to do it that way, that work would look like this. 5 3/4 would be 23/4. And then 3 4/5 would be 19/5. You don't need the original problem anymore. These are both going to be over 20. 4 times 5 to get to 20, so we need 23 times 5. That's 115. 5 times 4 to get to 20, so we need 19 times 4. That's 76. Add, we need 115 plus 76. That's a 191 20ths. And then we divide. 191 divided by 20. So go in 9 times. It's 180. Subtract, we get a remainder of 11 that goes over 20. Same answer. So you don't have to do any carrying if you go with improper fractions first. Let's do another. Let's look at 1 7/10 plus 5 3/10. 1 plus 6, or 1 plus 5 is 6. And since these are both already tenths, 7/10 plus 3/10 would be 10/10. 10/10, not a proper fraction. The big number, or the top number, is not smaller than the bottom number. They're the same. And we know what 10 over 10 is. Anything over itself is 1. Our answer is 7. If we went with improper fractions, 10, this is 17/10 plus 10 times 5 is 50, 53/10, which would be 70/10, which is 7. Either way, you get the same answer. That's new for addition and subtraction. Multiplication and division, we know we would not get the same answer. Let's do another. 13 1/3 plus 14 5/9. We need to get a common denominator. That's 13 3/9 plus 14 5/9, which would be 27 8/9. No muss, no fuss. Five 1/19 plus 8 18/19. If you want to rearrange, you can do that. 5 plus 8 plus 1/19 plus 18/19. 13 plus 19/19 is 13 plus 1 is 14. Or you can write it vertically, that's fine too. 5/19 plus 8 18/19, 13 19/19 is 13 plus 19 19ths, which is 13 plus 1, which is 14. Or you can go improper fractions, but we're not going to show it that way. That's a lot of work, and we know it's going to get the same answer. How about subtraction? Same rules. 7 and 7/8 minus 3 and 5/8. We do the same thing, but we subtract this time, not add. 7 minus 3 is 4. 7/8 minus 5/8 is 2/8. And we can reduce 2/8 to 1/4. 4 and a 4th. Some questions might ask you to do an estimated difference as well. That doesn't mean go 17/4. It doesn't want an improper fraction. It wants an estimated difference. So let's round these both. 7 and 7/8 is closer to 8 than 7. 3 and 5/8 is closer to 4 than 3. So our estimated answer, it would be about 4. Let's do exact and estimation again for our next one. 11 and 3/4 minus 2 and a half. We need to get a common denominator. Fourths. The first one won't change, but the second one, 2 and 1/2 is 2 and 2/4. Subtract 11 minus 2 is 9. 3/4 minus 2/4 is 1/4. And if we were estimating these, 11 and 3/4 is closer to 12 than 11. 2 and a half is right in the middle, so it rounds up to 3. 12 minus 3 would give us an estimated answer of 9. What about the improper fraction way? We can do that with subtraction as well as addition. I should show that at least once so you know that's true for subtraction, like you know it's true now for addition. 4 times 11 is 44, plus 3 makes 47/4. 2 times 2 is 4, plus 1 makes 5/2. Get our common denominator of fourths. 2 times 2 is 4. 5 times 2 is 10. 47 minus 10 gives 37/4, and then we divide. 37 divided by 4. We get a remainder of 1, which goes over the 4. So 9 and a 4th happens that way. Why do I want to show you that this works? Well, just like mixed number addition had a process similar to carrying the 1, mixed number subtraction is going to have something similar to borrowing. And borrowing is already a little bit tricky with whole numbers. With fractions, maybe you don't quite understand the process. So I want to assure you that if you just go improper fractions, subtract, and bring it back to a mixed number at the end, you'll get the right answer. Like this one, 9 and a half minus 8 and 3/4. I'm going to do this one as improper fractions first so that we can get the correct answer. This would be 2 times 9 is 18 plus 1, 19/2, minus 4 times 8 is 32, plus 3 is 35/4. If we make these both fourths, the The second one doesn't change, but the first one has to be times 2. 19 times 2 is 38. So this is 38 fourths minus 35 fourths, which gets us a nice answer of 3 fourths. 38 minus 35 gives us 3. Keep the 4 on the bottom. If we try to keep them as mixed numbers, we'll go ahead and we'll get 9 and 2 fourths minus 8 and 3 fourths. And notice 2 fourths minus 3 fourths, that's going to go negative. We can't do negative yet. Like Bob Saget, we don't do negative. What we can do is borrow. So if we look at this problem, 9 and 2 fourths minus 8 and 3 fourths. 9 can be rewritten as 8 plus 1. So this is 8 plus 1 and 2 fourths minus 8 and 3 fourths. One and 2 fourths as a mixed number would be 6 fourths. So we can imagine that we have 8 and 6 fourths minus 8 and 3 fourths. 8 minus 8 is 0, no whole number. 6 fourths minus 3 fourths would be 3 fourths. So all that borrowing, we did get to the correct answer. And if it was confusing going across, that's fine. I'll show it going down as well from this same point. We would have another rewrite step. 8 and 1 and 2 fourths minus 8 and 3 fourths. The 1 and 2 fourths becomes 6 fourths. 8 minus 8 is 0. 6 fourths minus 3 fourths is 3 fourths. So just 3 fourths. This isn't multiply. Remember, that means add. Mixed number has an addition between the whole number and the fraction. And now I'm going to show a trick. A trick, you say? Yes, a trick. And I'm going to do this trick from the original problem. This will work on any mixed number subtraction problem. It's always nicer to subtract just a whole number. Because if we didn't have any fraction involved here, the fraction subtraction is the hard part. Fraction subtraction. Whole numbers are easy. 9 minus 8 is 1. So let's guarantee that the second number is going to be a whole number. How can we do that? Well, we're going to add. And whatever we add to one number, we're going to add to the other because we have to keep it all even. Can't just randomly change something and expect to get the same answer unless we make the same change everywhere. What would we have to add to 3 fourths to turn 8 into a whole number? Well, 3 fourths would need another 1 fourth to turn this into 4 fourths. And then 8 and 4 fourths would just be 9, 8 plus 1. So let's add a fourth up here. 9.5 plus 1/4 would be 9 2/4 plus 1/4, which would be 9 3/4. 9 minus 9 is 0. 3/4 minus nothing is 3/4. 0 and 3/4 is just 3/4. Let's look at another. And I'll do it all the ways. 7 3/5 minus 6 1/3. If I wanted to use my trick, 7 3/5 minus 6 1/3, I'd like to subtract a whole number. I'd like to subtract 7. So to turn this into 7, I'd have to add 2/3, and I'll add 2/3 there as well. That turns this into minus 7. What's the top become? Well, 3/5 plus 2/3 would be 15ths times 3 to get 9/15 times 5 to get 10/15. This would be 7 19/15 minus 7. 7 minus 7 is 0, so the answer is just 19/15, which if we divide, is 1 4/15. And now you might be saying, now in these problems, you're writing mixed numbers that have improper fractions in it, but you said we can't have that. And I will say, I said we can't have that as the final answer. I never said we couldn't have that along the way to help us get to the final answer. So if we use our method of turning our second number of this subtraction into a whole number by adding up to get it to be a whole number, we get 1 4/15. If we do improper fractions, 5 times 7 plus 3, 38/5 minus 19/3. These have to be 15ths because that's the common multiple, the least common multiple of 5 and 3, times 3. 38 times 3 is 114, times 5, 19 times 5. That's 95. And then 114 minus 95 is 19. So 19/15. And when we divide, there's our 1 4/15 again. Whoops. One 4/15. What about our method of subtracting the fractions and subtracting the whole numbers? Well, seven and some number of 15ths minus 6 and some number of 15ths times 3 times 5. 9/15 minus 5/15 can be done. There's no borrowing. So that actually was the easiest way here. So maybe the method we're learning is for subtraction, unless we're going to use improper fractions for everything, which will work for multiplication, division, addition, and subtraction, but only has to be used for multiplication and division. If we're not going to go that way, then we should try this way first, see if there's borrowing, and we could either carry through with the borrowing or switch to our trick. Or if you want to be very careful, follow through with the borrowing and then do the trick anyway to make sure you come up with the same answer. With 3 different methods to do the subtraction problem, that's 3 different ways you can do it and see if you get the same answer. So really it all depends on the amount of time you have, the amount of time you want to spend. (19 6/7) minus 7 19/21. Let's try it the easy way. Let's get a common denominator here. That's going to be 21. So the second one doesn't change. The first one would have to be times 3 on the top because 7 to 21 is times 3 on the bottom. 6 times 3 is 18. Ooh, 18 minus 19, we have borrowing. Let's follow through on that. This would be 18 and 1 18/21 because 18 plus 1 gives us the 19. So it would be 18, 21 plus 18, 18 and 39/21 minus 7 and 19/21, 11 and 20/21 is our answer with borrowing, stealing a 1 from the 19, turning it into an 18, putting that 1 with the fraction we have because 18 plus 1 and 18/21 is 19 and 18/21, turning that mixed number into an improper fraction, 39/21, and then doing 18 minus 7 is 11, 39 minus 19 is 20/21. What about our trick, our subtracting a whole number trick? Well, let's go ahead and keep the common denominator. That was 18/21 on top, no change on the bottom. We would have to add 2/21 to turn this into the whole number, 21/21. So we'd also add 2/21 on top. This would then become 19 and 20/21 minus 8. 19 minus 8 is 11. 20/21 minus nothing is 20/21. The trick was nice here. And if you don't do the borrowing and you don't do the trick, you're stuck with improper fractions. 7 times 19 . So 7 times 19 is 133 plus 6 is 139/7 minus 21 times 7 is 147 plus 19 . 166/21, and then these both have to be 21s. Which means the second one doesn't change, but the first one needs to be times 3. 139 times 3. Carry the 2. 9 plus 2 is 11. Carry the 1. 3 plus 1 is 4. 400 17 21sts minus 166 21sts. 417 minus 166. 251 21sts, and then we divide. 251 minus 21. 11 and 20 21sts. Correct answer. A lot of work to get there. But if you're okay with that lot of work to get there, improper fractions, and then back to mixed number at the end will always get you the correct answer. No borrowing, no carrying, no tricks. Let's do another. This time we have a whole number 9 minus 8 and 5/7. We can borrow. We can make this 8 and 7/7 minus 8 and 5/7, which gives us our answer of 2/7. Why did I make 7/7? Well, because to subtract fractions, we would need a common denominator. Why complicate it? This one has a denominator of 7, so our other one should have a denominator of 7. And we're borrowing 1 because 9 is 8 plus 1, which is 8 plus 7/7. So that's with borrowing. Or we could use our trick and turn this into the easy version, where instead of a whole number minus a fraction, we have a fraction minus a whole number. So we could add 2/7 here, and then we could add 2/7 here, which turns this into 9 and 2/7 minus 9. 9 minus 9 is nothing. 2/7 minus nothing is our 2/7. The complicated way to do this, the complicated way to do every one of these is just to turn it into improper fractions and just do all your work that way. Again, it's longer. There we go. It's longer, but you don't have to worry about any tricks or any borrowing. It's just straightforward. This is 9/1. This is 56 plus 5, 61/7. Common denominator of 7ths. Second one won't change. The first one would have to be times 7 though. 9 times 7 is 63. 63/7 minus 61/7 is 2/7. Okay, maybe not that much more complicated with this specific example. We've got plenty more examples to go. Next up, let's take a look at 5 and 11/18 minus 2 and 7/9. Common denominator is going to be 18. First one won't change. The second one will. 9ths to 18ths is times 2. 7 times 2 is 14. We see that we're going to have to borrow. Before we do the borrowing, maybe we want to do our trick then. We can bump this up by adding 4/18. That'll turn 2 into 3. We'll add 4/18 here. That turns this problem into 5 and 15/18 minus 3, which would be 2 and 15/18. And we reduce 15/18. Divide them both by 3, 2 and 5/6. So that's our adding up to get a whole number trick. If we carried through with the borrowing instead, if I'm erasing too fast, then pause me. Rewind me, do whatever you need. If we go and do the borrowing, this would become 4 plus 1 and 11/18, which would be 4 plus 29/18, minus 2 and 14/18, gives us 2 and 15/18, which reduces to 2 and 5/6. Again, whole number plus fraction is the same as a mixed number. Or you can go a long way. Improper fractions. 18 times 5 is 90, plus 11 makes 101/18, minus 18, 19, 25, 25/9, which is 101/18 minus 9 times 2 is 18, 25 times 2 is 50/18. 101 minus 50 is 51/18. And if we divide, two and 15/18, which reduces to 2. Divide both by 3, 2 and 5/6. So we've seen 3 different ways to do subtraction of mixed numbers problems. We've seen that they all give the same answer. Know all 3, know 2 out of 3, just know one really well. That's up to you. You can practice in the homework problems. Let's talk about comparing fractions. What do I mean by comparing fractions? I mean choosing less than or greater than. This is less than, you could remember that because it makes an L. The way the signs work, remember Pac-Man will always eat the bigger number because Pac-Man's always hungry, always eating those dots. Sometimes he goes crazy and can eat those monsters. But picking less than or greater than when it comes to fractions. If we had 1/6 and 5/6, we can compare using the top numbers only, but only when the bottom numbers are the same. So because there's a 6 on the bottom of both, we can say 1/6 is less than 5/6. Pac-Man would eat the 5/6 because it's more than the 1/6. Four fourths and 1/4. The bottom numbers are the same. So this one's greater than because 4 is greater than 1. The bottom number isn't always going to be the same. We were comparing 11/30 and 8/15. We can't just say 11's greater than 8, so it's greater than. Because in reality, when we get the common denominator and we write the equivalent fraction for 8/15, 15 times 2 is 30, so 8 times 2 is 16. We see that 16 is the bigger number. So this is less than. This is less than. 11/30 is less than 8/15. This is also why we couldn't tell in the mixed number subtraction problems if we were going to have to borrow or not until we got to the step where the denominators were the same. Because before that, when there were different denominators, we didn't know for sure if the fraction on top was bigger than the fraction on the bottom. Because if it was bigger than it was on the bottom, we were able to subtract with no problems, no borrowing. It was only when the top fraction was not big enough to be able to subtract the entire bottom one. But once we brought them to common denominators, we were able to see, we were able to compare. And we need to have that same comparison in a problem like this. So if we had 3/2 and 13/10, and we needed to decide less than, greater than, what's going on, it's not enough to look at the 3 and the 13 because we don't have a common denominator. We don't have the same number on the bottom. But we can make these tenths, and the second one wouldn't change. The first one, we have 2 times 5 gets us to 10. So 3 times 5 is 15, and we actually see it's greater than. And just like with addition and subtraction problems, sometimes we only need to change one of the numbers. Sometimes we need to change both. 6 and 5 would have a denominator of 30. 6 times 5 is 30. 1 times 5 is 5. 5 times 6 is 30. 3 times 6 is 18. Once the 30s are the same, we can compare 5 is less than 18, so 1/6 is less than 3/5.